Welcome, smart mathematicians. Let's do question 10a. In the diagram alongside, f of x is equal to x cubed minus 5x squared plus 3x plus 9. Then g of x is equal to 3x plus 9. It's a straight line. And then f and g intersect at a. If h of x is the tangent at a, then calculate the coordinates of b, the x-intercept of h. Let's discuss this. We can find the coordinates of a. That's the first thing. We find the coordinates of a. How will you find the coordinates of a? A is a point of intersection between f of x and g of x. So we solve these two simultaneously by equating. Then we get the coordinates of what? Of a. Right, after getting the coordinates of a, we can find the gradient of the tangent h of x, because at point A, the gradient of the curve f of x and the gradient of the tangent are equal. If we derive f of x and substitute the x coordinate of A, we are going to get the gradient at A. Let me say it again. If we derive f of x, we are going to get the derivative, isn't it? And then we substitute the x coordinate of a into the derivative. We are going to get the gradient of f of x at a. And then that gradient of f of x at a is equivalent to the gradient of the tangent. If you check now, we will be having the coordinates of a and the gradient. And then using the coordinates of a and the gradient, we can find the equation of the tangent. And then when we get the equation, we can easily find the coordinates of b, which is what? B is the x-intercept of the tangent. So we can easily find the coordinates of b there. Right, let's just do those steps. First one, we're finding the coordinates of a. A is a point of intersection. So it means at a, f of x is equal to g of x. So meaning that x cubed minus 5x squared plus 3x plus 9 is equal to 3x plus 9. And then 3x minus 3x, remember when you transpose this, it becomes negative 3x. When you transpose this, becomes negative 9x. So 3x minus 3x is 0. 9 minus 9 is 0. So we remain with x cubed minus 5x squared is equal to 0. And then it becomes very easy to factorize this, because here we're going to use the highest common factor. Remember, for factorizing, always think about the highest common factor before you think about other ways of factorizing. Do we have a highest common factor here? Yes, we have the highest common factor. So let's factor it out. The highest common factor is x squared. And then what is x cubed divided by x squared? That's x. And then negative 5x squared divided by x squared, that's negative 5, is equal to 0. So meaning that x squared is equal to 0, or x minus 5 is equal to 0. Therefore, x is equal to 0, or x is equal to 5. It confirms that our answer is correct here, because we have the x value here, which is 0 here. So we have 0. And then we can easily find the y-intercept, because we have this, so this should be 0, 9. If we put 0 here, everything becomes 0, you remain with that, with 9. And then it means here a, we have 5. We need to find what? We need to find the y-coordinate of a. What are we going to do? To get the y-coordinate, substitute the x value, or the x-coordinate 5, into the function. So what is f of? We can use either of the functions here. We can use this one or even this one. You see that it will be easier to use the linear function, or g of 5 is equal to 3 times 5 plus 9, which is 15 plus 9, which is g of 5 is equal to 24. So therefore, coordinates of A, we have 5 and 24. The x coordinate is 5, the y coordinate is 24. So we have y 24 there. So that's the first step. So we have found the coordinates of A. Now we need to find the gradient of f of x at A, which is what? Which is equal to the gradient of the tangent. And then after finding the gradient of the tangent, we can find the equation of the tangent and find the x-intercept B. Let's just do that. Right, let's find the derivative. So f prime x, we're deriving f of x. So it's 3 times 1, which is 3, and then x to the power 3 minus 1, which is 2. So it's going to be 3x squared. Remember how we derive using rules. 2 times negative 5 is negative 10. And then x to the power 2 minus 1 is 1. So it's negative 10x. And then 1 times 3, that is 3. X to the power 1 minus 1, which is 0. So we remove 3. The derivative of a constant is what? 0. This is the derivative. Let's find the gradient at A. So we're going to substitute 5 into the derivative. So f prime 5, we get 3 times 5 squared minus 10 times 5 plus 3. Then we get that f prime 5 is equal to 28. So it means the gradient of the tangent is equal to 28. We have the gradient and a point on the graph. We have the gradient of the tangent, the straight line, and a point on the graph. So we can use our equation. Y is equal to mx plus c. We have y. Y is what? 24. Y is in the coordinates of A there. 24 is equal to m. M is 28, the gradient. And then x is what? Is 5. Then plus c. And then what is 28 times 5? 140. So 24 is equal to 140 plus c. And then we subtract 140 both sides. We find that c is equal to negative 116. Therefore, the equation of the tangent h of x is equal to 28x minus 116. So we have the equation of the tangent now. So now we can find the coordinates of B. B is the x-intercept. So x-intercept, where there is y, we put 0. X-intercept, we know that the y-coordinate is 0. So it's 0 is equal to 28x minus 116. Then we transpose. You bring the negative 116 this side. 116 is equal to 28x. Then divide by 28 on both sides of the equation. We'll get 29. You can use your calculator over 7, which is equal to x. So meaning that therefore the coordinates of B 29 over 7, 0. These are the coordinates of B. That's what it's supposed to do there.